Hey everyone, today we'll be going over Leetcode problem 102, binary tree level order traversal. In this problem, we're given the root of a binary tree, and what we want to do is simply return the level order traversal of its node values from left to right, level by level. So basically, we have an example down here where we have the root of the binary tree being a 3. 3 has two children, a 9 to the left and a 20 to the right, and 20 has also two children, a 15 to the left and a 7 to the right. What we want to do is return a two-dimensional list by going level by level and creating lists for each level, and afterwards joining them in a two-dimensional list, which therefore starts by going each level, level 0, 1, 2, and in each sublist having a traversal from left to right, with the 3 for the first level, 9 and 20 going left to right in the second level, and 15 and 17 going left to right in the third level. I have recreated the specific tree in the example to the right so that we could run through the algorithm needed to complete this level order traversal of the tree. It is important to know for many coding interviews that in order to complete a level order traversal of a tree from left to right of its node values, you will need to do a breadth first search. For a breadth first search, what you will need is a data structure known as a queue, which has first in, first out functionality, meaning you add the elements to the end of the list, and you take out elements from the front to the list, just like a line in a supermarket. We will start off by starting off with the root of a binary tree, which is 3. We will take the 3 and insert it into our queue. At this point, at the beginning of each level, we will determine the length of this level, or the level size. We know that in this case, the level size will be 1 because we only have the 3. After determining the level size, we know that we will need to pop out one amount of elements, because that is the total level size, and include this in our current level list. So we pop out the 3 from our list, and after canceling it out, we can include it in our current level list. So we have a 3 here. However, when taking out the 3, we need to include in the queue both of its children. So we take out the 3 and we put the 9 because it has a left child of 9, and a 20 because it has a right child of 20. After completing the level, what we can do is add this sublist to our output. So we have now a sublist of 3 as our first sublist. We can re-empty the current level and redetermine the current level size, which is now 2 because we have both a 9 and a 20. Once again, what we will do is start from the beginning of the list and pop out the element and add its children. So this time, we start with the 9 and we pop the 9 out. After popping the 9 out, we will go and add it to the current level, and then go and add into our queue its children. 9, however, as we see, has no children, so we do not have to add anything to the queue. We then continue by considering the 20. We need to pop off the 20 from the queue and add it to our current level. So after having added our 20 to the current level, we see that we have reached a current level size of 2, which was our predetermined current level size. Therefore, we are done with this level. However, when popping out the 20, again, we need to add its children. That the 20 has as its left child a 15, and as its right child a 7, so we have added these to the queue. Because we have completed the current level, we go and take the current level and add it to our output. And after having completed this, we can go and re-empty our current level. Once again, we redetermine our current level size, which is still a 2 because we have the 15 and 7. So we know we will have to pop out 2 additional elements before completing this next level. We pop out the 15 and the 7, and both have no children, so we will not have to add any more children to our queue. Once again, we have reached a current level size of 2, which is identical to the level size predetermined, so we have completed this current level. Therefore, we can add this current level to our output. After this, we can once again empty our current level, and in this case, because we have completed our current level and our queue is still empty, We know that we have completed our level order traversal of the tree. Because our queue is empty, a next level size would be 0, and so we are done. We therefore have completed our output, and we have completed our breadth first search, so we can return it. The time complexity of this algorithm is O of n, or linear time. And this is because we are traversing each and every node in the tree only once, in order to create this output. So we're back in Leetcode ready to write out our solution. We want to start off by taking care of an edge case, where the tree is actually an empty tree, so we have no root. So what we can do is check that if the root does not exist, and in that case return an empty array, because this is the case that we have an empty tree with no nodes to traverse. Afterwards, what we want to do is initialize our queue, and in Python we can do that by just declaring a deque. To this queue, we want to initially append the root of our tree. And afterwards, we can also prepare our resulting array, which initially will be empty. After preparing our queue and our resulting array, what we can do is start our breadth first search, and this will continue while our queue is not empty. At the beginning of each while loop, what we want to do is create a new current level array. So the current level list will initially be empty, but we will fill this out with all of the nodes in a specific level of a tree. Also, what we want to do is determine the current level size of a specific level at the given moment. So we can say that the current level size will be in this moment equal to the length of the queue. Afterwards, what we want to do is pop out an amount of nodes from the queue which is equal to the current level size. So we can say for I in range of current level size, and what we want to do in the beginning of each loop is pop out the node, so the node is going to be equal to queue.popLeft. And afterwards, what we want to do is append to our current level list the value of this specific node we just popped out. So we can say cur_level.append node.value. Finally, after adding the new node to our current level and having popped it out, what we want to do is add any of its children, if they exist, to our queue. So we can say if node.left, then queue.append node.left. And if there is a right child, we want to append that right child as well. Now, after each iteration of this for loop, we will have filled up our current level. Therefore, once done with this for loop, we're done with the current level, and we want to add this current level to our resulting array. So we can say res.append cur_level. Instead, when we are done with the entire while loop, we know our queue is empty, and then we are done with our breadth first search. Therefore, we could just return our result. Once again, this is a linear time solution because we are going through each and every node of the tree only once. Let's run this to make sure it works, and submit. And we can see that it's efficient. Thank you very much for watching this video. If you found it helpful, please give it a thumbs up and subscribe to my channel. I'll see you in the next one.